Now I can, my failure can be committed to all time. So we can rewrite that as sine, 2 sine x times what's the differentiation of what's ever left inside of the inner function, which in this case would be cosine x. I don't think we can carry that any further.
Agree with friends?
Well, that's what I got.
Yeah. Outer layer is square, right? So the derivative is 2 times sin of x. Then times by the inner function sin, right? Sin function derivative is cosine. So yes, you're right. Done. Good job.
Do you want to do the other one that I said I would do, or?
Oh, the next one I assigned to Brittany, right?
Yeah.
Right?
Well, you also assigned me the e to the e.
So let's wait until in order, okay? Let's wait in order.
Okay, I don't really know if I got this right, so we're just gonna try. So we have, you take the exponent and you bring it to the front, so you have your f prime of x equals 100, and then you leave what's inside, and then you subtract 1, and you have to multiply it by the derivative of what's inside, so that would be 4 minus 2x. Question mark.
Agree with Brittany? Yes or no? Good job. See, it's not that hard, right? Yeah. Okay, so Carrie.
All right, Carrie.
Yes,
Do words we can mention. Okay. So, I didn't know one, so where is it? Anyway, so back when she explained this, that's what we did first step. So
I can't quite see visual.
but it's such a tight area here. So 1 times x plus 1 minus 1 times x over x plus 1 squared equals, figure out something here, x plus 1 minus x plus 1 squared. X plus 1 squared equals
Agree with Perry? Okay, good job. That's correct. Okay. Did it? Yes, you did it. Okay. Good job. Okay. I'm gonna explain it one more time. Okay. Okay. So Terry and then the group and his group did a good job. Okay. This is really tricky question. It's not easy. Okay. So find the derivative of this function y equals square root of this whole thing. Okay, so square root of function, okay, we consider this as outer one, okay, this inner function, x over x plus 1, we consider this as our g, and the square root is our f, okay, f. So by using the chain rule, okay, we're going to differentiate the f, and and then x, g of x. Then times by what? Derivative of g of x, right? So, what is the derivative of square root? Remember, Terry just now told us, okay, square root of something equals 1 over 2 times square root, right? So, yes, okay, so square root of x plus 1 equals 1 over 2 times the square root of x over x plus 1. So, this is the first part of the, the chain rule, okay? Then multiply the derivative, okay? The derivative of x over x plus 1, right? So, I would say, we're not using, I would say, we're going to multiply by this, okay? Multiply by this. This is derivative of f times by the derivative of g, okay? The derivative of g, okay? So, what is derivative of g? This is derivative of g, okay? And then how to differentiate g, okay? By using quotient rule, we have x plus 1 square, okay? And then by using quotient rule, it tells us differentiate the top, give us 1, times by the bottom, x plus 1, minus differentiate the bottom, okay, which is 1, times by the top, which is x. Very good, okay? Yeah, so this part comes from the derivative of g, okay? And then x plus 1 minus x cancel out, so we have 1, okay? 1 over x plus 1 square, okay? So that's why we bring this part down and this part down, so together it gives us what? The product of these two. So yes, that's the derivative of what? Y, okay? I will not put an equal sign here because this does not equal, okay? Y is y, but the derivative of y equals this times by that is this, right?
I was just going to say, for the rule that we had to use there, would it be fair to say that the generally applicable version is the nth root of x equals 1 over n times the square root of x?
Nth root.
Yeah, the nth root.
Oh, nth root.
So,
You're talking about this?
yes,
So this is x to the n.
is equal to, no, that's not what I meant, but is equal to 1 over n times x, times the square root of x, I should say. I think that's the generally applicable form.
Oh, okay. You're talking about the nth root of x, right?
Yes.
Okay. Yeah. So there is a general formula there, but the general one we don't use that often. Okay, we use the square root most often. So that's why I want you to just remember that. Okay. So if there is a cube root, what are we gonna do? We write a cube root and x to the 1/3, and we use power, we can get a cube root. Okay. But as you said, yes, if this is n in general. This is x to the 1 over n's power, so it will be equals 1 over n times by x to the 1 over n minus 1's power. This is in general, okay? But you...
Sorry.
Yeah, you don't...
It's easier for me to think.
Yeah, okay, yeah, okay. So this is question A. Everybody clear about this one? It is tricky, okay? It is, okay? Alright, so this is question A. Now let's look at question C. Okay, yeah. I will do this one for us, okay? So... remember we talked about trig functions, some exponent can be written by this. So we can tell the square is the most outer layer, okay? So the derivative equals, what is the derivative of a square? Power rule, right? 2 times by cotangent sin of c. We call it whatever is in the, of the square, okay? As a base of the square. So 2 times of this, okay? However, by using chain rule, we have to compute the derivative of this inner part, right? So multiply by cotangent of sin of sinus derivative, right? What do you think? This is chain rule, right?
Yeah.
Difference is the outer layer and then times by whatever left, okay? And then how to differentiate this part?
You find the root, the first different, sorry, I don't know the word. The first is, it's cosecant squared.
Yes. Cotangent compared with sin is outer layer, right? Cotangent is like outer than sin. So when the difference cotangent of sin theta. What is the derivative of cotangent? Do you remember? We learned it last time. What is the derivative? Negative cosecant. So negative, I write it in front of entire line, okay? Cosecant square of what? Sin of theta. Okay, it's not cotangent theta, it's cotangent of sin of theta. So the derivative of cotangent should be negative cosecant square of sin theta. But are we done? No. Derivative of sin. This is a most inner one, right? So negative 2 times by cotangent of sin of theta, and then times by cosecant square of sin. What is the derivative of sin function? Cosine theta. See, we talk about 1, 2, 3, 3 layers. So eventually, okay, I'm talking about eventually, the derivative should be a product of 3 factors. Okay. For some intermediate steps, see this one, there are only 2 factors, but we haven't done for this part. So from the derivative of this part, there are 2 factors comes out. So together with the first one, 3 factors. Everybody? All right. Can we move on to the last question? All right. Last question, Brent? All right. So.
Well, because Euler's number is such a fun number when it comes to derivatives, the first order derivative is very simple. Because e to the x is its own derivative, I'll put first, would be e to the x times e to the x.
Which is, Brent, the first derivative, right? Just use chain rule once, done, right?
The second derivative is a bit more tricky because you have to use the product rule. So second, well, that will be, whenever I have to use the product rule, I find it useful to write my f and f prime and g prime. So f prime, f is e x, and then f prime, e to the x, and we just did that, times e to the x. F prime. G. Am I now? Sorry, am I better now? G would be e to the x, and g prime, check my notes, I believe that will be it's just e to the x. Am I still in familiar territory?
Yeah, you're good. I'm right here.
So then we have, so now we can use the product rule, which is e to the x prime times e to the x, and that expands out into e to the x times e to the x times e to the x. Oh, sorry, plus e to the x times e to the x. And we could stop there, but it's not very neat or orderly, so we would want to combine our terms. So e to the x times e to the x would be e to the 2x, e to the x plus e to the x would be 2e to the x. Oh, no, sorry.
You don't have to simplify if you don't want to.
No, I can just leave it like that, but there are a few terms that could be cleaned up there. The simplest one to clean up would be this one. e to the x times e to the 2x plus e to the x times e to the x. And I think that's neat and early enough for our purposes.
This is a correct answer, guys. Okay? Folks, Grant, you did a good job. Okay? I'm gonna explain to you very quickly, okay? F, we're not done yet. G, okay, so second derivative should equals what? F prime times G plus F times G prime, right? What is F prime? Here. This is F prime here, okay? So that's how we have e to the x times e to the x. Times g, what is g? E to the x, which is here. Plus f, what is f? E to the x. Times g prime, what is g prime? E to the x, okay? So eventually, okay, answer is going to be what? E to the x times by e to the what? 2x plus e to the x times what? E to the x. You guys? Okay, good.